Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we're going to introduce this section on two-dimensional vectors. So in this topic, I'm just going to step through the topics we will see in the next few lectures. I'm going to re-emphasize at the end the need to do problems which you can download from the course website. In the sequence of topics, we will begin by describing what a two-dimensional vector is. Sometimes they're interpreted as arrows pointing from the origin to a point. Other times you can just interpret them as ordered data. We will then see how we can calculate the length or 2-norm of a vector. We will then describe a unit vector, that is, a vector with a 2-norm equal to 1. We will then see how we can add two vectors together. For example, the sum of the red and blue vectors gives the purple vector here. Similarly, another example of the adding of two vectors. We will then show how we can multiply a vector by a scalar. For example, multiplying these by 0.8 or multiplying them by negative 1.2. We will then see how we can calculate the difference or distance between two vectors. We will then see how we can normalize a vector so that the scalar multiple has unit length. We will then describe vectors at right angles, or in other words, we will show how and when two vectors are said to be orthogonal. We will then introduce the concept of the inner product, or as you may have heard it described, the dot product. We will then step through and see the relationship between the inner product and the 2-norm, or length of a vector, and the inner product and orthogonal vectors, or vectors at right angles. We will conclude by finding all vectors that are perpendicular to a given vector. Now, recall, on the NE 112 website is a related document, a primer on vectors. You should download this and read through it while you are watching the videos. The section numbers are correlated, and there are additional questions which you can try out with some answers attached to each section. Please do these questions. So, in this topic, we've introduced the topics we will see in this section that focus primarily on two-dimensional vectors. As you go through these topics, you should read the corresponding primer and do the exercises. Here are some references, acknowledgements, the colophon, and a disclaimer. Cheers!